I'm honored today to be able to moderate this great panel at today's Global Network Forum, which we're going to take 5 different deep dives into various aspects of our commercial space commerce industry. My name's Eric Stallmer. I'm the president of the Commercial Spaceflight Federation. CSF is a trade association that represents about 75 different member organizations with a dedication to promoting and protecting the commercial space industry. So as I mentioned, today we have 5 incredible speakers who are amongst the most knowledgeable and well-regarded in our global space community. We're going to, as we cover these 5 areas, the first will be space communications and surveillance for national security with Dr. Fritz Merkel, and that will be followed up with Rob Meyerson, president of Blue Origin, who will speak about reusability of launch vehicles. Following Rob will be Travis Langster, vice president of government relations for AGI, who will be talking about space situational awareness. And then we have Dr. Bruce Chesley of the Boeing Company, who will be talking about the impact on constellations. And then wrapping all this up will be Peter Marquez, of the Vice President at Planetary Resources, who will discuss, among other things, bringing all together the role of policy, legal, and the regulatory stability has in supporting commercial space activities and spurring growth and innovation throughout the world. So it's a very exciting panel for the next 2.5 hours that we have. Just the format of how we're going to run things today. Each panelist will get up and talk for about 25 minutes or so. And then what we'd like to do, time permitting, is have everyone come back up to the stage on the podium and do a little Q&A. So, but before I get started with all that, I really would like to thank the IAF Industry Relations Committee. I know Mary Snitch, Mary's right there, and Clay Morey, who have been so helpful on this, and really putting together just such an outstanding panel. And throughout, not just my panel, I'm biased because I think this is the best panel of the day, but there's several other of the GNF forums that are going on that are just all outstanding, and the amount of work that Mary and Clay and their whole team has put together has just been outstanding. So, why don't we get started with Dr. Fritz Merkel. I would just give, because I'm not sure if you have bios, I'm going to just do a really quick overview of each of the panelists. But Dr. Merkel is a member of the executive board at OHB SE in Bremen, Germany, which will be our host city for IAF next year, so please come to Bremen, fantastic city. He has been with OHB since 2000, but during that time, he's been a member of the executive board, which is a responsibility for some of the defense programs, advanced studies, and business development at OHB. Prior to that, he was vice president at Carl Zeiss Corporation, and as a systems engineer and a project manager with the European Southern Observatory in Garching, Germany, where he was responsible for the optical systems, active and adaptive optics, and long baseline interferometry, I barely got that right, so that in itself is impressive, of the European's Very Large Telescope. An assistant professor of physics at the University of Heidelberg, where he's got both his degrees, his doctorate. A member of the International Academies of Astronautics, AIAA, and several other organizations, and he's been referenced over 100 times in various publications and journals. Without further ado, Dr. Fritz Merkel.
Good morning, ladies and gentlemen. Thank you very much for inviting me to give here a short overview, a deep dive. I think it is, when I looked into this topic, and you may have seen the topic has also a little bit changed in the programs. There's even another title. So I looked into the topic, how I could do a deep dive. It certainly was like diving in the Pacific Ocean and Atlantic Ocean at the same time, but these 2 oceans are somewhere related. So let me try to do it in a few minutes to give you a short overview. So they put the wrong presentation on it.
Say it loud, and I'll run back.
Could you please take the other presentation from the stick? Because that's the one which was in the agenda. Okay. So on the topic, communication and surveillance for national security. First of all, what does mean national security? OHB, we are working for the German government and for the European Union on security issues, basically by providing telecommunication satellites, Earth observation, reconnaissance satellites, and navigation satellites. Because in a way, navigation satellites are a type of communication satellites which communicate a very special signal. And then the question is national security. National security is somewhere divided. It is a military security, defense-oriented security, but also it is the civil security of all citizens, either in a state or, like Europe, also in a way in a federation of states. So on this, OHB has been acting as a prime contractor over many years, since approximately 2000. And if we look to communication, what is an important point on communication for our security? It is, on one hand, the availability. Ground-based communication always carries the risk that it may be affected by natural disasters, by hostile actions, and therefore, space communication is an essential point. On the other hand, it is essential if warfighters, soldiers, rescue teams are somewhere in the world, they are in areas where usually then they have not access to the local communication system, if it is at all existing in this region. So communicating from space is a very important issue. The question then is, in which spectrum? Then I said, to do a deep dive in an ocean, one has to see. So it's a wide spectrum. What type of communication should come? Oh, thank you very much. Yeah, and so main point is mainly on geostationary satellites. We have the spectrum. That means we know geostationary satellites broadcasting television programs, multimedia features, but here in security, it is also the question, what frequencies are relevant? There's a wide spectrum, and in particular, if there's a huge amount of data and secure data to be transmitted, it has to be really, let me say, important that these frequency spectra are secured, are not jammed, are not distorted by hostile actions, and will be available, and then in particular also in case of natural disasters. Just take even in civil security the point, 20, 30 years ago, we could make telephone calls when there was a blackout, no electricity available, because typically all phone systems had their own electricity supply, typically even battery boosted. If today there is a blackout, after a few minutes, all our communication poles somewhere distributed on house roofs or somewhere will stop, so our mobile communication system will not work anymore. In particular also, it is IP-based. That means computer server systems will stop working and we have no access to the population anymore or to whatever security action has to be taken. So to have space-based communication systems will be an essential contribution to civil as well as national defense security. Yeah. Then second dive in another ocean means surveillance. That means in order to secure citizens, to secure soldiers, warfighters, it is essential to have sensors which gives them data in which environments they are acting, what happens on the world, where are critical zones, where are natural disasters, where are hostile actions. What we know most is electro-optical sensors, and just a typical image here, what you see, that's a soccer stadium in Bremen, so whoever comes next here may even have then match observed by Werder Bremen in the stadium. And just also, it's not one of the most advanced electro-optical systems. It has not been built. What you see on the right side is a generic image. We have not yet delivered a high-resolution optical system, but we are in the process of developing. But even you can see what is a little green image above. So that's a center line of the soccer stadium observed from roughly 700 kilometers in space. So it's even possible to see this circle in the center. And this is an important point. While on communication, it is using the full spectrum up to today several 10 gigahertz, it is on the optical then and the imaging, the resolution. What fine details can be observed? And in optical, and now I have to be careful what I say, whether these are data typically our customer use or what is physically possible. So reasonably physical possible is to go down to the 10, 15 centimeter range in optical resolution. Below this, surveillance from space in the optical domain gets difficult, not because the telescopes have to get larger and larger, but because the light passes through turbulent atmosphere. And this distorts the image quality. The question then again is, in which spectrum I observe it. Whether it's in a visible, then it only will work during daytime, during time when the sun illuminates the ground. It's a little bit better in the infrared because the Earth is also radiating infrared radiation, so we can see in the infrared also during nighttime. Detectors are a little bit more complex, and the telescopes, in order to get the same sharpness of images, have to be larger and larger. So from this point, now one has to see what is the right approach. But nevertheless, there's one restriction. The sun, we need sun or the light radiated from Earth, and we have to make sure that there are no clouds, which is a difficult issue to assure, so we have to rely on cloud-free moments. I think in the average, 60 to 70% of the Earth's surface is covered by clouds. That means optical observation, electro-optical observation, only works in the moments when we have free zone. If we observe in the optical, our eye, we see in 3 colors. Advanced electro-optical detectors today go up to 6, 7, 8 colors. We are currently even developing and building, it's in the middle of construction, a satellite which is observing in 220 colors. That means we add by this another domain of observation, not only the geometrical image and in colors as our eyes is used to, but with 220 spectral bands that separate the light, we can do a spectral analysis of the image. That means what is seen green, for example, if we take the security issue, for example, an olive green military truck, with this sensor, one could say, who is the manufacturer of the green paint? Because the pigments are always slightly different depending on what chemicals the paint manufacturer is using. Or if we take it over to another application, agriculture, if a field is green, we usually think it's good, there's enough water. But if you analyze the green, you could then even say there's a stress of water, of mineral missing, the field needs fertilizer, or say even insects and pesticides which affect the growth of the plant. So one could add, in addition, the dimension of spectrum to these observations. But while in the electro-optical domain, then one needs light from the sun, there is another possibility to illuminate the ground from space. And this is one of our specialties when I talk about OHB, but there are some companies which do excellent sensors in the radar domain. Typically, they are called SAR detectors, SAR sensors, synthetic aperture radar, because the resolution they deliver is much larger than the antenna size would give it. That means by computational methods, the image size or the aperture size is calculated to match even several kilometers in dimension. And with this, extremely high resolution can be obtained, and if the microwave wavelength is selected in a way that it goes even through clouds or during rain time, one can observe 24 hours because the satellite illuminates the ground to get the images. These sensors, typically, if one goes in the X-band, that means around 10 gigahertz, allow to get to resolutions today in the range of down to 10 centimeter, maybe even a little bit better. It's not yet implemented to our knowledge, but we know how to do it, so that's something quite interesting. And what you saw here, if I just go back on the left side, this is an artist's view, but we have delivered already 10 years ago 5 of these satellites, and they're in full operation by the German Ministry of Defense. And currently, we build a second generation, and there you see 3 satellites. One is slightly different, looks different. We have 2 technologies we apply there. We have a partner for one technology. The reflector antenna type is our main used technology. One is a phased array as a reflector technology. Often say that reflector technology is a classical old-fashioned way, phased array is an advanced way. But today, for security, there's a main difference. All phased array satellite systems today are so energy hungry, you have to operate them in a dawn-dusk orbit. They need permanent sunlight on their solar generators. While the others are more economic in the use of electricity, prime electricity and can be operated over a night period in space by batteries, which has, for security application, the main issue because then you can observe whenever there is a need. If you depend on sunlight, like the electro-optical sensors, you can only observe roughly half of the day if there is cloud-free. But security, disasters, hostile actions do not occur according to times. That means if you fly on dawn-dusk orbit, you can observe 6 o'clock in the morning, 6 o'clock in the afternoon. Hostile people usually do not behave and would follow this. So from this point, one has to see what fits best to the needs. Now, if we have sensors flying in space, they're flying typically on low Earth orbit. That means 90 minutes around the Earth. That means typically one has a few minutes contact to download. And now we can see one can and should combine for security measures Earth observation satellites with communication systems, not to have the data directly sent down, but preferably beamed up to geostationary orbit, and then a satellite can be roughly for 30 minutes in contact with the ground station. That means by proper setting up a geostationary relay system, one can have permanent contact to satellites. And this is a system we are currently building, a communication satellite, which will, by laser link Earth observation satellite to geostationary in order to have a direct access roughly for 30 minutes over the area of Europe. This will be done by optical links. So in communication, optical transmission, optical communication will more and more play a strong role. And this is in particular important then also for security operations, because the communication has to be safe, not been jammed, not been taped. And in the future, quantum encryption will be possible if there's optical communication. That means really full secure communication. So technology also we are, and many industry companies are working on. Often it's said the 20th century was the century of the electron, 21st century will be the century of the photon. Quantum cryptography may play there an important role. Then I would like to add navigation satellite also as a communication satellite, because what is a navigation satellite? GPS in Europe, Galileo, OHB, we do all 30 Galileo satellites. It is basically transmitting a precision time stamp. And if you send a signal from 3, or in practice you need 4 satellites, you can triangulate and you have exactly the position. So it is a link between both. And in addition, for example, the Galileo system will even have an emergency feedback channel. That means if there's somewhere a disaster in the world, or let me say a ship or an airplane in stress, they could send via this navigation signal a call for rescue, which automatically would put then the location stamp and time stamp on where the critical issue comes from. Yeah, and in order to do this, one needs high precision clocks. Even in future, advanced clocks, optical clocks may play a role in order to have not only permanent access with precision imaging data, but also then with a very high absolute geolocation. Okay, all this needs appropriate ground station, fixed station, mobile station. So in a way, it is a complex field which we have here, and it is one of the traditional fields even in space technology, because the first Earth observation satellites date back to the 60s with film rolls. Today, very advanced sensors which data, for example, in our radar system, one image will just fit on a Blu-ray disc, one image. So in a way, it's a huge amount of data. Data have to be brought together in ground station. In order to transmit this huge amount of data, one needs extremely broadband communication system, which leads to the fact one has to go to new frequencies, which protect and which have to be protected, jam resistant, etc. Okay, this as an overview. As I said, it was a difficult dive in 2 oceans, 3 oceans, and but this area is really an extremely challenging field, in particular also because it brings space very close also to the citizen by protecting him in his civil security as well as his military security, which is a national task to keep citizens safe. Yeah. Thank you very much.
Thank you for that great overview, Fritz. Now, our next panel discussion, our deep dive, will be from my friend Rob Meyerson, the president of Blue Origin. Rob will be talking about the reusability of launch vehicles. Rob Meyerson is the president of Blue Origin, where he has overseen the steady growth of the company since 2003. Blue is developing reusable launch systems to enable a future where millions of people are living and working in space. At Blue, for those who have not seen this most incredible factory up in Kent, Washington, the vehicles and technologies under development include the new Shepard system for suborbital human and research flights, the BE-3 rocket engine and the BE-4 engine, as well as the orbital launch systems that they're creating. Prior to joining Blue, Rob was a senior manager at Kistler Aerospace, also in Washington, responsible for landing thermal protection systems of a 2-stage reusable vehicle. Rob began his career at the Johnson Space Flight Center, with NASA's Johnson Space Flight Center, where he led the aerodynamic design of the shuttle the Space Shuttle Orbiter Drag Parachute, as well as the overall design and integration of and flight test of the gliding parachute for the X-38 crew rescue vehicle project. Rob earned his bachelor's degree at the University of Michigan, Wolverine, in engineering, and a master's degree of engineering and management from the University of Houston. Rob Meyerson, doing great things in Washington and all over the world. Thank you, Rob.
Thank you, Eric, and thank you to the entire IAC, the City of Adelaide, South Australia, and the whole country of Australia. It's great to be here, great to be back, and on behalf of the entire Blue Origin team, I'm delighted to be speaking to you here at the 68th International Astronautical Congress here to the space community. Our vision at Blue Origin is to enable a future where millions of people are living and working in space. This vision was set forth by our founder, Jeff Bezos, whose passion for space exploration began when he watched the Apollo 11 missions to the moon unfold on television. It was this event, watching Buzz and Neil take their first steps on the lunar surface, that sparked his lifelong passion for space. And I know that many of you in this room have had the same similar experiences. I know I have. Earth, this blue planet, is our origin. It's our blue origin. And we at Blue Origin aim to dramatically reduce the cost of access to space so that someday we can expand humanity into the solar system. In time, we see the movement of heavy industry off Earth, which will allow humanity to enjoy this planet for centuries to come. When I spoke at last year's IAC, we were about to launch our New Shepard rocket for the 5th time. New Shepard was the first rocket to fly to space and then land back vertically on Earth. We then repeated this mission 4 more times in less than a year, demonstrating what we call operational reuse. In that last mission, our goal was to test the emergency escape system. This system is designed to separate the capsule from the booster to keep the astronauts out of harm's way should there be an anomaly detected during flight. I remember noting here last year, in Guadalajara, of course, that I had hoped the rocket would land safely, as we were not expecting the booster to survive the 70 pounds of thrust that the solid rocket motor would exert on the booster when it fired to eject the crew capsule. I also said that I'd hoped we would be able to show off the retired booster after a historic 5 flights. Now, if you've seen this video, you'll know that my hopes became reality. During the mission, the escape system operated perfectly. New Shepard just showed us just how robust it is when it flew through the exhaust plume, went to space, re-entered, and landed gently back on the launch pad. It looked as nominal as the 4 landings before it. It was really amazing and very emotional for me and the team to watch from West Texas, where we launch and land the New Shepard vehicle. This test, of course, was a very crucial test for us in our development program, and our customers have responded in a big way. We not only plan to fly people on New Shepard in the coming years, but we're flying science payloads today and in the future. Our manifest is full, and that's as a result of the robustness of the system and the ability to demonstrate the capabilities that a suborbital space platform can offer to the science community. After this series of accomplishments and the torture that we put our booster through, we decided to take it on the road and show the world what a flown rocket looks like. Here's a photo that we're particularly proud of. There you go. This is our rocket at Oshkosh, in Oshkosh, Wisconsin, at the EAA Air Venture. There's a 1-to-1 crew capsule, high-fidelity mock-up of the crew capsule in the photo as well. And as you can see, the crowds were extremely excited to come and check it out. Now, to top off this incredible series of accomplishments in this year for New Shepard and the team behind it, we are honored to receive the Aviation Week Laureate Award, the Robert H. Goddard Memorial Trophy, and the historic Collier Trophy, all for New Shepard's accomplishments in reusability. I'm so proud of our team, and I congratulate them for their efforts to bring these recognitions to Blue Origin. Thank you. So let's move from the past and let's talk about the future. And let's talk about some of the exciting new developments for Blue. We revealed New Glenn, which is named after Mercury astronaut John Glenn, our orbital rocket that's going to launch from Cape Canaveral. We're almost complete with the New Glenn assembly factory down near the Cape, and are making great progress towards completion of this facility at the end of the year. And on early December, the first week of December, we'll be moving our folks in and starting the integration of the first New Glenn vehicles. Now, New Glenn will have the capability to take people and payloads to orbit. The rocket will be powered by 7 of our BE-4 rocket engines, each generating 550,000 pounds of thrust. That's a total of 3.85 million pounds of thrust, well over 17,000 kilonewtons. New Glenn's manifest is also filling up. And last year, we announced 2 customer contracts for New Glenn with Eutelsat and OneWeb, and we can't wait to take these important customers to space. And today at IAC, I'm proud to announce another exciting agreement, this time with MuSpace, an advanced technology company, a mobile network operator based in Thailand. MuSpace is working to support Thailand's fast-growing demand for mobile data using terrestrial and space-based solutions across the Asia-Pacific region. We have entered into an agreement with MuSpace on a future launch of a geostationary satellite aboard New Glenn early in the next decade. We look forward to launching MuSpace to serve the people of Thailand and the Asia-Pacific region. Now, MuSpace's CEO, James Yen Bam Rong, is here today, and I'd like to invite him up on the stage. James? The response to New Glenn has been phenomenal, and I really want to applaud Clay Morey and his team for the fantastic job they're doing filling up the New Glenn manifest. Now, in addition to signing on new customers, we've also been listening to them, and our customers have provided very, very valuable feedback to the design of the vehicle. Based on this feedback, we've decided to skip the 5.4-meter fairing design, which was our first increment for New Glenn, and go straight to a 7-meter fairing. This feature will be available for first launch, and the 7-meter fairing, back up one. The 7-meter fairing has 2 times the usable volume of the largest 5-meter fairings that are flying today on the market, allowing more usable manifest for dual manifest missions, usable volume, orbiting large LEO constellations, and it also allows greater freedom of design for our customers. It's going to be the biggest fairing on the market today, and I encourage you to check out our website at blueorigin.com for more information about New Glenn and its capabilities. And now on to the BE-4. BE-4 has also seen measurable progress this year. We delivered the BE-4 hardware to our West Texas launch site for testing and have more engines in the pipeline. The future beyond New Glenn has also become clear, and we at Blue feel that it's time to go back to the moon, and this time to stay. So this year, we proposed a lunar cargo delivery concept that we call Blue Moon. We're using proven technology from our New Shepard program, including our BE-3 engines, to do an early demonstration of a large cargo landing architecture. Blue Moon enables the delivery of more than 10,000 pounds of usable payload to the lunar surface. The private investment made in New Shepard and in the development of the BE-3 engine enables this kind of technology work to be done in just a few years. And we want to work closely with NASA on this program. At Blue Origin, we're building launch systems for what we call operational reusability. This starts with the design philosophy for our family of launch vehicles. Both New Shepard and New Glenn launch systems are built to fly to space and return to Earth time and time again. So we want them to fly more like a commercial aircraft and not like an expendable rocket. New Shepard is our first step towards achieving full operational reusability. It is reusability being proven, and let's take a closer look into how this system works. The New Shepard mission will take 6 people to space on an 11-minute life-changing ride. Each customer will get to experience the thrill of spaceflight and become an astronaut. During this flight, the rocket takes off and lands vertically about 2 miles away from the launch pad. Astronauts on board the crew capsule will experience a real rocket ride, accelerating to nearly Mach 4 atop the New Shepard booster. Once the capsule separates from the booster, our customers will enjoy up to 4 minutes of weightlessness above the Kármán line, with the ability to leave their seats and enjoy views of the Earth from the largest windows ever to fly into space. After returning to their seats, they'll return to Earth using a classic parachute landing, just like the Apollo astronauts. Right now, and since the government-sponsored space industry started, we live in a world where we throw away our rockets after just one use. If our goal is to get millions of people living and working in space, then we need to reuse our vehicles so that we can lower the cost. This means we need to think creatively and iterate on the smart decisions of the past while creating new ideas to achieve our mission: launch, land, repeat. With New Shepard, we're aiming to fly suborbital missions at a rapid pace, as frequently as once a week. The rocket you see here incorporates a number of features, both aerodynamic and propulsive, that enable it to be reusable. If you look at the top of the chart, the ring fin is the key part of that technology. And the ring fin serves as the structure that attaches the capsule to the booster. And it also provides the separation mechanism to support separation at apogee or at the engine cutoff. It also supports the fins, the aerodynamic fins, and the drag brakes that support re-entry stability and deceleration prior to landing. The drag brakes deploy about 20,000 feet above the ground. The fins at the aft end of the rocket serve to steer the rocket back to the center of the landing pad. And then once you're above the landing pad, the engine lights up, the BE-3 engine lights up at 3,600 feet above ground, supporting enough deceleration to slow the rocket down, deploy the landing gear, and touch down softly on the pad, as we've done many times before. The historic booster we showed you earlier flew to space 5 times and back, and often under very extreme test conditions. For the first 3 of those missions, we didn't even take the BE-3 engine out of the vehicle. We did a full breadth of inspections. We used a borescope, which is a small camera, to look inside at all the small parts of the rocket to make sure it was ready to go again. And then we loaded it up with fuel, and we went again. The BE-3 engine, this is a cryogenic engine that's built to be deeply throttleable. And what I mean by that is that it can power the booster for ascent at about 110,000 pounds of thrust. It can throttle all the way down to 20,000 pounds of thrust smoothly through that whole throttle profile. Most rocket engines on the market can throttle down to about 70,000 pounds of thrust. So this is a real innovation in rocketry that hasn't been seen since some of the demonstrations of the lunar lander engines back in the Apollo program. What this does is it enables a very soft and very predictable landing for the rocket booster, enabling reuse so that you can get the hardware back, you can inspect it, and you can turn it around to fly again. Equally important is that New Shepard is designed to be extremely efficient to operate. We can fly New Shepard at less than 1/50th of the going price of an orbital launch system. What this means is that it allows us to fly often and learn as we test, roll those lessons learned back into the design for New Shepard and also for New Glenn that will come after it. And this is the key part of our incremental development process that we call it Blue Gradatum Ferociter, or step-by-step ferociously. So here's New Glenn. With New Glenn, we're designing a very large and very robust launch system that will be capable of launching large payloads and people into space easily without having to squeeze out every last ounce of performance from the rocket. We're landing New Glenn's first stage on a moving ship. That means a more stable deck with less pitch and roll for more softer and more reliable landings. And the design philosophy even goes to our choice of fuel for the BE-4 engines. We chose liquefied natural gas, which is essentially commercial-grade methane, not just because it's plentiful and available from many qualified sources around the world, but we chose it because it's inexpensive. It's less than 1/4 the cost of rocket-grade kerosene. It's also self-pressurizing, which allows us to eliminate helium from the design. Helium is a very, very expensive and a very precious gas in limited supply. And then most importantly, it's clean burning. So there's no coking or toxic residue that comes about in a cryogenic LNG engine that's left on the engine or the nozzle post-flight. So this allows us to easily prepare the engines again for reflight. New Glenn also has strakes on board. These are the wings that are located at the base of the rocket. These strakes provide lift upon re-entering the Earth's atmosphere, and coupled with these, the strakes and other aerodynamic and propulsive features, they give this rocket, New Glenn, the highest weather availability on the market, allowing us to launch and land in over 95% of weather conditions. You can see the strakes there at the bottom of the rocket. So. And the most important part. There we go. So we are embracing operational reusability from the beginning. Our step-by-step approach will yield tremendous results in the near future. Operational reusability is the key to achieving dramatic cost reductions, unleashing a dynamic space economy that will benefit life here on Earth. Thank you very much.
Rob, thank you so much for that inspirational talk. It is beyond words to watch the advancements that Blue Origin has been making in the past few years and really changing the industry and the way we do business in the launch, from the launch perspective. The next panelist I'd like to bring up, next speaker, is my good friend, Travis Langster, who's the Vice President for DoD and Intel Space and Business Development at AGI. In this role, Travis is responsible for the strategy and business development within the national security space community. Travis supports the solution-oriented applications of AGI software for many of the national security space systems. His responsibilities also include supporting the international space situational awareness community. Travis has over 20 years of professional experience in business development, program strategy, and capture, strategic planning, corporate initiatives, technical management, systems engineering, and operational support. Prior to joining AGI in 1996, Travis began his aerospace career as an engineer with General Electric Aerospace and then moved on to Lockheed Martin Space. Travis is a member of the Aerospace Association of America, Aerospace Industries of America, and serves as the Space Situational Awareness Committee Chair. He's also a member of the American Institute of Aeronautics and Astronautics and the Armed Forces. Travis earned his Bachelor of Science degree from an aeronautical and astronautical engineering with a minor in math from Purdue University, go Boilermakers. And rumor has it that Travis was seen climbing to the top of the rooftop at the Adelaide Oval on Monday, all the way to the top. So glad your legs are still available to come up for these next few steps. Travis, thanks so much for joining us.
Thanks, Eric. I am definitely honored to be speaking here at the Global Networking Forum of the 68th IAC. My talk is going to really highlight the challenges of space situational awareness, and hopefully if we get time during the discussion, we'll talk about some of the opportunities to address these challenges. So operating satellites has never been more challenging. We all know that outer space is quickly becoming more crowded real estate. The more traffic, the higher the risk of collision. This video depicts the growth in the number of objects tracked since the very first satellite in space. You'll see there are a few peaks that happen throughout the growth of the catalog. A few of those, the Iridium Cosmos collision, as well as the 2007 China ASAT test. What you may not know is the number of objects actually tracked in space is largely unknown. The public catalog currently has over 23,000 objects. However, That's only up to or down to 10 centimeters in size. There are many more objects in space that are currently just not able to be tracked. My colleagues at the Center for Space Standards and Innovation put together an assessment leveraging the statistical catalog and debris catalogs from NASA and ESA to develop this video to show the number of objects that are actually in space. And you can see the number of objects once we get to 10 centimeters, but beyond smaller than 10 centimeters, there's a lot more up there. And this is in the LEO. So effectively, today's public catalog contains less than 4% of the number of objects that are in space, greater than 1 centimeter in size. The same challenge exists in the GEO. The space population is especially unknown in GEO because of the challenges being able to track down to 2 centimeters in size in the geosynchronous belt. It is well known that object sizes of 2 centimeters or greater are the ones that can create catastrophic debris generating events. This video depicts the same situation in the geobelt, as well as objects that cross through the geobelt, so roughly plus or minus 100 kilometers. Okay. Again, roughly 4% of the objects actually passing through the geobelt are actually known. There have been a few wake-up calls, events in space that have awakened us to the dangers and challenges of actually operating in space. This video depicts a Breeze rocket body that exploded on orbit, causing dangerous, scattered, and moving debris field. Of course, we all know about the well-publicized and known Iridium-Cosmos collision. What we don't know is, or at least it may not be well known, there are actually other debris-generated events that have occurred. Fortunately, operators do get warnings about these events. Unfortunately, the number of warnings they get is enormous, and the accuracy with which they can make decisions is often insufficient. Here's some real-world events that really show that operating in space is indeed rocket science. Over the last 3 months, there have been at least 3 satellite anomalies. This particular one shows the AMC-9 that lost control. And when I say anomaly, it means the operators lost complete control of the satellite. Working through AGI and through the ComSpoc, we were able to help AMC-9, as well as other operators in the particular region, figure out what was going on, essentially be able to characterize the situation. So in this particular case, it shows the AMC-9 traversing through the geobelt, and you can see other satellites in the region. What we're able to do with the ComSpoc is provide warnings, conjunction warnings, and provide detailed technical assessments of those particular satellites. This was the next event, EchoStar. Also had a satellite anomaly, or again, lost control of the satellite. The equivalent, from my perspective, these things happen. It is rocket science, but being from Washington, D.C., my analogy is it's like a 18-wheeler driving around the Beltway without a driver. Maybe it's at nighttime, so it's not rush hour, but the number of satellites that are going up in space, it will soon be rush hour in the geobelt. Several satellites come within close proximity. Also, as a public service, the ComSpoc did identify another operating satellite operator, not a subscriber to the ComSpoc as a service, but we warned them ahead of time. 8 hours later, they maneuvered to avoid a close conjunction. The last one here in this example was Telcom. Telcom also lost control of the satellite. Interesting story here. We got an email through our traditional email alias that asked, what does it take to become a ComSpock subscriber? 8 hours later, they were customers. So again, those are real-world events of what can take place in operating satellites. So given this is a deep dive talk, I felt obligated to provide some numbers. This depicts the number of encounters over the next 10 years in non-intervening operations, of the number of collisions that could take place, the number of warnings that a satellite operator may get, and the number of maneuvers that a satellite operator may have to make to avoid a collision. I'll draw your attention to a few of these here, particularly where you see as many as 2 million warnings could come across Boeing's desk in the next 10 years if all of these operators are able to achieve what they're shooting for. This is very much requires a machine automated type capability and process. In honor of the anniversary of the Outer Space Treaty, I also felt obligated to highlight not just the congested part of operating in space, but sometimes there are unknown activities, some in the DoD call it contested space operations. So this is a depiction of satellite operations of a particular satellite, SJ-17 in this case, that the ComSpock tracked. Thought it was very interesting maneuvers that were taking place, not the traditional types of maneuvers for operating satellites for the purposes of satellite communications, for example. In this particular case, the rocket body and the satellite payload rendezvoused and performed proximity operations around another satellite. So I offer these terms for how I and others use the term space situational awareness. I picked these up, the first one, space situational awareness, from the Australian Space Academy. I did throw in a couple of words there, particularly in terms of current and predictive. Space situational awareness does require predictive assessments and capabilities. And then you see space traffic management as a subset, and it involves the regulatory aspects that help manage not only the physical, but the physical and or radio spectrum aspects of managing and operating in space. So I offer, in closing here, commercial SSA services. The market continues to grow. AGI, ComSpock, we're not the only ones out there providing these services, but in terms of operationally providing capabilities to those who operate in space, that's here today, and it will only grow the more operators we have operating in space. I think I'll close there and wait for more discussion.
Thank you so much, Travis, for that great overview. I'd like to next shift gears into the impact of constellations this morning, presented by Dr. Bruce Chesley, the Senior Director of Strategy, Space, and Missile Systems at the Boeing Company. Bruce is the Senior Director for Strategy and Space at the Boeing Company, a position that he was appointed to in July of 2017. Bruce leads a team charged with analyzing the marketplace, establishing a growth strategy, and helping shape the future direction of the Space and Missile Systems Division, which includes the International Space Station, government and commercial satellite systems, a range of missile defense and strategic defense systems, deterrence systems, including ground-based mid-course defense, missile defense national team, and the Minuteman intercontinental ballistic missile systems. Prior to the current position at the Boeing Company, or his current position, Bruce led the Boeing Company's global broadband systems program within the Network and Space Systems Division. Bruce has served in several leadership positions in business development for the N and SS position, starting as the leader of the global sales and marketing, where he's responsible for customer service, customer engagement, new business, advocacy, marketing efforts, research and development investments, M&A, business unit strategy, and leadership development. I don't know where you get all the time to do all that, Bruce. He also serves as one of the chief architects at Boeing, responsible for the technology investment and product development for the current and future needs of the business for space exploration, cybersecurity, missile defense, satellite systems, missile and commercial space application. Bruce joined Boeing in 2000 after a career in the United States Air Force, where his assignments included Air Force Space Command and the National Reconnaissance Office, as well as the Department of Astronautics at the U.S. Air Force Academy. He earned a doctorate in aerospace engineering at the University of Colorado Boulder. He holds a master's of science in aerospace engineering from the University of Texas at Austin and a bachelor's from the University of Notre Dame. We were discussing the challenges that he has having to root for 4 different college football teams on any given Saturday. He's the author of numerous papers and book chapters on space engineering and satellite design. Bruce, welcome aboard.
Thank you, Eric. It's a pleasure to be here with you today at this International Astronautical Congress, and it's a privilege for me to be here representing Boeing, where we believe that space systems have the ability to connect, protect, explore, and inspire the world. And perhaps, in my opinion, in no areas is that more true than in the area of satellite constellations. And when you think of what's driving the motivation to think about satellite constellations, it's really all of us. We have increasing demands and expectations for ability to consume data whenever and wherever we are. And the growth in just total available or total bits that we want to consume is doubling, more than doubling, every 4 years. And so this exponential growth in demand is driving people to think about new ways of servicing those new needs. And it's easy to think that those needs are driven by the smartphone revolution of the last 10 or 12 years, and certainly that's a big part of it, but there are always new products and services that are coming into market, such as the in-home assistance that you see there, all the way to autonomous vehicles in the future, just continuing to drive that explosive demand for connectivity and content. And the other thing that's happening is the types of bits, the nature of the bits are changing. And so you can see that on the right side, streaming video is becoming a much more important component, growing at a larger rate than other types of consumption. But there's also need for low latency bits and bits with other characteristics that are continuing to evolve the types of services and the types of demands on satellites in particular to serve this future connectivity market. And we think satellite will be an important part of that connectivity market, but really when you step back and look at the total telecommunications industry, satellite is less than 2% of the total market. And so the question is, how is the global enterprise going to service this growing demand? And so let's start with a look at what terrestrial services offer, since that's the bulk of where broadband data connectivity comes from. And the reality is that broadband connectivity is limited largely to urban and densely populated areas. If you look at the map of the US there, you can see very broad swatches of the country where there's not terrestrial broadband available. And even in the areas where terrestrial broadband is available, if you look at the bar graph in the middle, Some 63% of U.S. households really have access to one or fewer provider. So the choice and competition is dramatically reduced for the vast majority of Americans. Now, it's not, I speak to America because that's where I'm from, but the problem is not restricted to the United States, of course. I've got Great Britain up there as an exemplar for the rest of Europe, and you can see, again, vast areas of white on the map, showing that terrestrial broadband access is also limited. And in fact, if you look more broadly across all of Europe, there are some 225 million Europeans who lack access to broadband. And this in Europe and the United States, despite government policies and incentives to provide broadband to all citizens. So, you know, the challenge is great, and I should note, you know, the legend at the bottom shows the definition of broadband is also somewhat modest in contrast to these future needs. You know, 25 megabits per second or 16 megabits per second in the case of Great Britain. You know, that is probably not enough to sustain whatever the vision is of integrated media services as they evolve into the future. So turning our attention to Australia, of course, Australia is a vast landmass and a distributed population, and so they have similar challenges to the challenges that we see here in the U.S. and Europe. The government here has instituted the National Broadband Network as a way to address this with NBN and its distribution partners, and according to their latest annual report, NBN now provides broadband access to more than 25% of households and businesses in Australia, and that's a number that's growing at an accelerating rate. So, you know, the challenge is really ubiquitous and really has opened up the aperture for people to start thinking about expanded services using satellite constellations as a way to help address this. And there's really four main factors that kind of motivate the introduction of these constellations for broadband. One is mobility. We all have an increasing expectation to take our data with us on the move, and that's becoming even more prevalent on airplanes, and as we think of autonomous vehicles, the demand for data will continue to grow there. Satellite systems are great in that they radiate the Earth indiscriminate of whether an object is stationary or in motion, and so satellite you know, is incredibly attractive as a solution for mobile type solutions. The other thing is the flexibility of the infrastructure. As Dr. Merkel mentioned in his discussion this morning, you don't necessarily need to pull dig a trench with a backhoe and pull a new cable to a new location in order to install a satellite user terminal. And so that flexible infrastructure allows a scalability that satellite offers that other approaches have a difficult time matching. The other advantage of satellite constellations is just ubiquitous coverage. The white spots on the map get covered up uniformly by a satellite constellation. Now, there are challenges with capacity density in terms of being able to provide enough satellite capability into a densely populated urban area, but the distribution is nevertheless uniform of that capacity across the entire map. And the final advantage and feature of LEO constellations and non-geostationary constellations is the dramatic reduction in data latency as compared to GEO. And many applications that are evolving relative to 5G networks, autonomous vehicles, and even interactive video kinds of applications are driving a need for more lower latency types of connections. And so for those four reasons, it really has shifted the balance in the satellite operator world to express more interest in having non-geostationary satellite constellations available. And so kind of summing that up, you know, GEO really is still the prime real estate in outer space, and you know, has the great advantage that one spot beam can cover a huge proportion of the Earth. Unfortunately, there's also large proportions of water that get covered in a traditional satellite, and so what we've been doing at Boeing over the last several decades is really leading the digital transformation of satellite payloads in order to provide spot beams and concentrate capacity in the areas where those users are, where the paying customers are, to be honest. And taking that digital capability and bringing it down into MEO architecture is essentially what was announced 2 weeks ago by SES as part of their O3B mPOWER constellation that we're proud to be partnered with them as a manufacturer of that new system to provide a low latency, high throughput system. And then as things evolve into LEO, of course it requires hundreds of satellites instead of tens of satellites at MEO to provide continuous coverage across the entire Earth. But you also get the advantage of having increased capacity density by having the satellites much closer to the Earth, as well as an additional factor reduction in data latency. So it's really not a one-size-fits-all, and what we're seeing from our operator partners is a desire to take the best attributes of all of these orbital regimes and blend them together to meet the business needs of their particular environment and their particular objectives, to provide a mix of GEO, MEO, and LEO capabilities to meet their emerging needs. And so this kind of wraps that up and says, okay, in addition to GEO, MEO, and LEO, as operators are looking at more managed network services and moving the bits in a way that's most advantageous for their particular application. So if it's a broadcast linear TV bit, maybe those bits want to be over a geosynchronous spacecraft. As they become broadband backhaul and lower latency bits and more interactive kinds of services, they might move down into more of a MEO or a LEO kind of a system, especially for mobile or aeronautical kinds of applications. And then enterprise and home and dense urban environments where terrestrial wireless has an advantage. You would route signals across those. And so as this whole landscape is evolving, this is what we're seeing in the managed network services area, is a blend of each of the attributes of not only space systems, but space systems really as an overlay of terrestrial wired and wireless networks. So in order to enable these satellite constellations of the future to provide this broadband capability, there's really two precious natural resources, if you will, that need to be carefully managed and shared in order to enable these kinds of systems. The first one I'll start with is in the area of spectrum. Spectrum, of course, is the lifeblood of all of our satellite communication systems, and in order to enable these LEO constellations, LEO constellations have the potential to provide these very small grids of directed capacity on the surface of the Earth. But frankly, the terrestrial wireless industry is also wanting to provide similar kinds of high capacity services and increasingly wanting to use spectrum that has been traditionally allocated for satellite and repurpose that for terrestrial applications. This is a big issue for all of us satellite manufacturers, and we are extremely active ourselves and in concert with our other manufacturing partners and the satellite operators and all of the important satellite industry associations around the world, working with regulators in order to protect this spectrum. And in particular, as we look at some of the higher spectrum areas, the Q and V band and millimeter wave areas, which have yet to be fully exploited by either satellite or terrestrial means, we feel like modern technology and smart policy can really enable sharing to have the best of both worlds, where satellite and terrestrial can coexist successfully to enable these new services and these new markets on the spectral front. In terms of orbits, of course, the orbital environment, as Travis was talking about, is a critical feature for these satellite constellations to be able to operate safely and predictably within the space environment. And managing that environment is critically important, and cooperation and transparency are absolutely critical there. You know, many people don't appreciate that Boeing has been part of the Iridium constellation from the beginning in terms of constellation management and collision avoidance and providing automation to all of those processes in order to streamline that. And building on that experience, we've developed our concepts for how to manage large LEO constellations using that. And you know, it starts with a precise understanding of where the satellites are and maintaining that precision knowledge. And once we know where the satellites are, then we station keep those satellites within a sphere. That's roughly 7 kilometers in radius for this example, which is roughly the distance from here to where we stand now to the Adelaide airport, assuming many of us came through there in recent days. And then once we know the satellite's within that sphere, then we maintain the separation distance through careful phasing of the orbit planes at a distance of greater than 45 kilometers, which is related there to the size of Botany Bay over in Sydney, to maybe overuse the local geographic references a little bit. And then, you know, essentially that pattern gets repeated throughout the entire constellation and then neighboring constellations in order to maintain and preserve a safe operating environment for any and all satellites that are operating in that area. Now, the concepts are simple, and the implementation is, of course, never been attempted on this scale that's being contemplated with some of these very large LEO mega constellations. And so, you know, certainly additional automation and lessons learned are going to be needed as we evolve into this constellation-driven future. So in summary, you know, it really is the exponential demand and bandwidth that is driving us to consider providing these kinds of constellation services and new satellite constellations. It's really revealing some creative thinking about how to address these markets through a combination of traditional GEOs as well as adding MEO and LEO services to those systems. And we need to continue to work very aggressively as a satellite community to preserve access to spectrum and to protect the orbital environment in order to really enable this new era, a real revolution in satellite capability that we're on the cusp of here. And in closing, I want to reflect a little bit on some of the terrible incidents that have happened in Mexico and connect that to what we're doing here. A couple weeks ago, I had lunch with one of our customers from MEXSAT, which is a system that Boeing built for the government of Mexico several years ago. We handed it over to Mexico for operations, full autonomous operations on their part, about 18 months ago or so, and the system is designed to provide military and government and disaster relief with continuous mobile voice and data coverage across the entire country of Mexico. You know, all the rugged terrain and remote areas that exist in that country. And you know, when the the series of earthquakes has hit over the last couple weeks, there were power glitches in Mexico City, and so the primary ground station in the suburbs there at Ixtapalapa cut over operations to the backup ground station seamlessly up in the northwest part of the country in Hermosillo, and the backup station was able to then, more importantly, control the satellite payload, move the satellite capacity where it needed to be in order to aid the emergency response. And there are a number of instances where, you know, lives were saved saved the civil defense forces and the Mexican military forces that were brought in, you know, had the MEXSAT radios strapped to their vests. They were able to expedite rescue operations and aid and recovery operations. And so, you know, we talk a lot at this conference about how space systems really benefit all of humanity, but this to me is a really touching and humbling and gratifying reminder of that, of how the systems that we develop can really save lives and really connect and protect people around the world. Thank you.
Thank you so much, Bruce. I just want to remind everyone in the audience, this is the Global Network Forum, so what we hope to be doing afterwards is networking a little bit, but we can start with that with some questions from the audience. So I know that there are volunteers, I see one right there, with some questions. If you would like to fill them out, raise your hand, she'll come to you, Isabella will come to you, and fill out the questions, and we can facilitate them here on stage. So Peter said that, you know, we are now saving the best for last, in his own words. But in the final deep dive that we have Peter Marquez from the Vice President of Global Engagements for Planetary Resources. Peter is going to talk about the topic of policy, legal, and regulatory stability in supporting commercial space activities and spurring growth and innovation throughout the world. Peter, as I said, is Vice President of Global Engagements. He's responsible for planetary resources outreach and cooperation with all governments to support the development, launch, and operation of the company's spacecraft mission. From 2007 to 2010, Peter served in the White House on the National Security Council as the Director of National Space Policy, where he led the development of the 2010 U.S. National Space Policy. Peter oversaw the development, implementation, and coordination of all space policy under Presidents Bush and Obama. Peter's policy responsibilities, in addition to space, also included critical infrastructure protection and military intelligence activities. He also oversaw regional security issues focusing on Asia. While at the White House, Peter also began the initiative that created the U.S.-Japanese Strategic Space Cooperation. Peter has a bachelor's degree in political science and a master's degree in Science and Technology Policy from the George Washington University in Washington, D.C. Peter, the stage is yours.
Well, with that intro, let me underwhelm all of you. So again, thank you for the introduction. Clay, thank you for having me here, and thank you to the folks at IAC for having me at this event. As it says up there, I'm supposed to talk about near-Earth objects. If you are on the flight going to near-Earth objects, this is not your flight. I don't know how NEOs got on there. All I know about NEOs is that if one came through the roof right now, it would be a bad day for us. I know that my company is going to be mining some of them for resources, but I will not be talking about NEOs. So if you want to get up and leave, I will not be offended. I will be hurt, but I won't be offended. Okay, all right, so we're not going on a NEO trip. I did talk about mining asteroids, which is cool. Sounds fun, sounds exciting, sounds next generation. And there's a lot of things going on in space right now that are exciting, that are groundbreaking. But whether it's the new exciting stuff or the stuff that we've been doing for a very long time, what I want to talk about is kind of 3 ingredients that are necessary for making the recipe and the 2 cooks that are involved in making that recipe work. So I'll use this terrible analogy over and over again in my comments today about the 3 ingredients and the 2 cooks. The 3 ingredients are understanding a purpose and goal and what you're trying to achieve. The second ingredient is the knowledge and capability to make that happen. Now, knowledge and capability can be a variety of different things. Immediately, the space community goes to the technical capabilities. What kind of knowledge do I need to make that happen? But there are other capabilities that come into play. It was touched upon just in the previous comments about the regulatory environment, the laws, the procedures to make those things happen. And then the last item is funding. Nobody likes to talk about funding. For some reason, it besmirches the romance of space if we talk about needing to fund things. But I will tell you my experience when I worked at the White House. When I worked on policy issues, I would sit in a meeting. There would be folks there from NASA, folks there from the Department of Defense and the intelligence community and wherever else. And the budget guys would sit in there and they'd say, this is all great. These are all dreams and all aspirations that you all have, but unless I give you the money for it, they will remain dreams and aspirations. So the funding part is another critical, important ingredient in the recipe we're trying to make. Now, there's two chefs involved in what we're trying to make, and those two chefs, in my opinion, are the government and industry. Sometimes the government's the head chef, and sometimes the government's the sous chef, and sometimes they switch back and forth. But having those two cooks in the room working on those three ingredients can give us an opportunity to create something amazing, whether it's this new fun stuff or it's the stuff that we know how to do but need to do a little bit differently. So I got here from saying I wasn't going to talk about NEOs, and now I've segued into government, and I'm quite proud of myself for getting out of doing NEOs, so I pat myself on the back for that. Now, everyone here is at this conference or in this room because they believe in doing space for one of probably a few handful of reasons. There are those of you here that are the explorers, that want to go back to the moon or go to Mars or do something in cislunar. It's the explorers. There's those of you that come from my old historical community that are the peacemakers, that want to see security and stability in space and utilizing space to make sure that there is peace on Earth. There's the business people that are here, that there's a business, a market to be had through utilizing space. I want to be very clear. It's through the utilization of space, and I'll touch on this in a minute. It's not about being in space. It's about utilizing space. Then, of course, there's the scientists here amongst us, those that think that space is the place where we're going to find out why we're all here or how we exist or why the reality exists. It's usually those four groups of people that are here at a conference like this. And they're all passionate about being here. Everybody here is very passionate about what they do. It's a very energetic environment. Everybody loves this community. And I was going to go a different route with some of my prepared comments. I had a very lengthy flight here and had a good idea as to what I wanted to talk about. But last night, as I was going through the opening reception and some of the people I met this morning, I also want to tailor things a little bit for the younger crowd, the younger professionals that are here. I've been doing this for 20 years. I am a deep cynic. My wife says that I curmudgeon at least a 65-year-old age, so I'm an advanced cynic. But what I see often is, and I think all of you that have been in this community for a while, is the people who come in that are young, that say, I'm going to change the world through space. And they come in and they're bright-eyed and bushy-tailed and ready to make a difference. And then in a few years, they wash out. And then a new group comes in and says they're going to change the world and make a difference. And what I want to do is try to talk to some of you all, because I don't want you to fall into some of the same traps that I've fallen into and that others have fallen into, and talk about how government and industry and understanding the recipe and understanding the ingredients can get you to a point that you don't wash out. Because some of you have amazing ideas and have great ideas on how to move things forward, and I don't want to see you leave this community. So let's start with the first goal, and I'm using my notes here. I'll use my jet lag as a good excuse for my poor public speaking ability and use my notes that are here. So the first ingredient I want to talk to is the purpose and goals. They are uniquely important, and I think it'll be the thrust of most of what my commentary is. To paraphrase a George Harrison lyric, or to really mutilate a line from Alice in Wonderland and the Cheshire Cat's line, which is, if you don't know where you're going, any road will take you there. And often we find ourselves in the space community saying, it's space, it's cool, I'm going to go do it because it's space. And then you find out, well, I don't really know why I'm doing this. Why am I doing this? What's the goal? What's the purpose? What is the road I'm trying to get to? What is that goal? So for me, when you're talking about your goals and purposes, coming from the policy community, I immediately think of policy and what that does. What are you going to do? How are you going to do it? And why are you doing that thing? Now, the first two, I think, are pretty explanatory. What are you going to do? How are you going to do it? But the why. And the why is something that leads to that very first trap that I often see young professionals wash out of the community from. And that is, why are you doing this thing? And it's not about space. Okay? Let's take the IAC here as an example. I don't know, how many people are registered at this conference? How many people are here? Was it 4,000, 5,000? What is it? 5,000? All right. So you got 5,000 people here. Most passionate people about space represented amongst the 5,000. And let's take the topic, what this whole session is called, the Global Networking Forum. We're supposed to be talking to each other, networking, and figuring out how to help each other. The people here at IAC are your allies. We're all in this trying to figure out a way to do something, provide a service, provide a capability, do something different, whether it's, the explorer, the businessman, the scientist, or the peacemaker. We're all trying to work together to find out how to accomplish that goal. But when you're working with the people here, and you're working with the two chefs, they can give you access to two of the ingredients. They can give you access to the capability, and then most of the time they can give you access to the funding. But what they can't help you with is the goals and purposes. That's for you to figure out. And part of the reason is, and I say this with all dear, true love and respect to my fellow space brothers and sisters, is that space people give you an answer to the why that has to do with space. And I'm going to say something that I've said before, but for those of you that haven't heard it before, it's provocative and it gets people upset, and I'll do it anyway because I'm that kind of guy. Space doesn't matter. It just doesn't. It doesn't matter. Space does not matter. Here at the Global Networking Forum, I would like to take a broader definition of that phrase. It should be truly global. You should be reaching out beyond the space community. The 6,000 people that are here, 6,000-ish people that are here, those are already the true believers. You don't need to convince any of them of what you're trying to do, what you're trying to accomplish. So let's take an example that's near and dear to my heart, the planetary resources. We're a robotic mining company. I didn't say we're a space mining company. I said we're a robotic mining company. We just happen to operate in space. I may come from a space background, and my company may operate in space, but the things that we do are much more aligned with traditional mining than it is with anything having to do with traditional space activities. Now, we're going to space not because it's something cool, which, undoubtedly mining asteroids is pretty cool, but the reason we're operating there is because the resources are there. And it's the same reason that mining companies all over the world go to where they mine. Nobody thinks it's any different that you go mine in a desert, or you go mine in a jungle, or you go mine in the ocean. It's just you go where the resources are. So let's go back to the why. Why are you trying to accomplish what you're trying to do? You need to be talking about the entire globe, making it relevant to people, making it relevant to industry, making it relevant to government as to what you're trying to achieve, talking to the two chefs to better understand what it is you're trying to get out of the kitchen. Let me give you some examples of trying to understand the why. The first one I'll use is, as Eric mentioned, I was involved in the U.S. National Space Policy. And what happened in 2010 is we finished the policy, I had it written, took it to the president and said, okay, policy's done, we're good to go. So POTUS takes a look at it and he says, okay, this looks good, but why? Why are we doing this? I said, well, what do you mean, why are we doing this? Are you going to tell NASA what to do? You got to tell the Department of Defense what to do? He's like, I understand, but why to the rest of the country, the taxpayers, are we doing this? Find me the reason why, and then I'll sign this. So I went back to my office, and I had no idea. I mean, you're asking a policy guy to write something that is almost prose. I don't know how to write prose. I know how to write bullet points. So what I did is, I know enough to know that I don't have any good ideas, but I know where to find them. So I went back to the Eisenhower administration. I went back to the person whose records, the person who had my job for Eisenhower, and I went back to his records and found out when they had written the policy, Eisenhower had asked the same damn question. This is great, you guys want to do the space stuff, but why are we doing it? And in that, I found a line from my predecessor from the 1950s. What he told Eisenhower was, and this appears now as the first line in the U.S. National Space Policy, which is, through such exploration, man hopes to broaden his horizons, add to his knowledge, and improve his way of living on Earth. Now, it's the 1950s, so they used male terms. I apologize. We'd use it a little different now. But I thought that was a good summation. We're not going to space because it's cool. We're going to space because of what it provides. So that made its way into the policy. The president was happy, and we've got a national space policy now. Another example is the planetary resources example again. As many of you know, the US government passed a law that allowed companies like mine to own the resources that come from asteroids, the resources that we mine off of those asteroids. The very first few times I went into Congress to go talk to either representatives or senators, there was more than one occasion where a congressman would laugh and look at his chief of staff and say, is this for real? Are you guys putting me on? Is there some joke that's going on that I'm not aware of? One thought he was on a hidden camera show. They didn't think it was real. somebody comes in and wants to talk about asteroid mining with a congressman. He just got done talking about, God knows what, and now you want to talk about asteroid mining? It's insane. What it was, though, and what got to the point of why Congress went ahead and passed this law, and passed it unanimously without a single person voting against it, is that it wasn't about space mining. It wasn't about something cool, wasn't about something different. It was about something that by just passing a law enabled new technology to be developed, created high-quality jobs, and provided access to strategic resources. And not only that, there were some members of Congress that looked at the amount of money we were talking about and saw it as an enormous amount of taxable revenue. So we made it relevant to what they were interested in, and in that process, we found out something about ourselves as well. That's part of that process where we found out we're not a space mining company, we're just a mining company who operates in space. I had a similar experience about a year and a half later when I started working with the government of Luxembourg. And as you know, the government of Luxembourg has something called the Space Resources.lu initiative. So obviously by name, very focused on space resources. And has also passed a law that not only does with the US law, but goes a step further. And without getting into the Outer Space Treaty, it allows us to have Article 6 coverage, and it's all kinds of very great things. But what I think I really enjoyed about working with the government of Luxembourg is I was working with a group that understood the roles and responsibilities and the equities of both chefs in the kitchen, government and industry, and then understood why they were doing these things. That it was about creating capability, about creating revenue, about economic diversification, about creating technology, about creating something new in that country that was a great benefit to not only them now, but in the future. So it was a wonderful experience to have. So again, when you talk about why, it's not about space. It's always been about achieving a broad strategic goal that is agnostic to the medium. So the why is important. Now, I want to very briefly go into some of the other two ingredients, which are the knowledge and capability and the funding. Now, the space community is pretty good at, when you get into the knowledge part, like I said before, about tackling the technical parts. That's the first thing anybody says. I want to go build a satellite program. Okay, cool, for what? Well, I want to communicate. Awesome. What are your, what's the power level? What bands? Have you got your ITU filings in? And it's like, okay, yeah, we do a really good job at that. What we don't do, and I will use the communications folks as actually a good example, is I did mention the ITU filings. What we don't do a very good job at is understanding the policy, legal, and regulatory capabilities, opportunities, or impediments to what we try to accomplish. We attack the technical parts first, but often have a blind eye until it's too late. I'll use a non-space example. If Uber had known very early on that they were going to run into a variety of regulatory issues in just about every area that they had went to go operate in, they probably would have taken a different tact early on with their political and legal engagement that would have saved them several $1 million in legal fees later on. It's those types of things of understanding how that works. And so when you talk about the two chefs, industry needs to get in and talk to the government often to figure out what the considerations are and how they can best position themselves to take advantage of those opportunities. In the U.S., we call it the Chicago voting rules. For those of you that don't know, Chicago had, I don't know, what would you say, a dubious political history, some ethical issues on voting. So the Chicago voting rules are, on voting day, you get in there early and you get in there often. So it's the same thing with space activities. Get into the government folks, let them understand what you're trying to accomplish, and get in there often so that they can try to help you accomplish what you need to get done. On the funding part, like I said at the beginning, everything is aspirational until you have the resources to make it happen. That means you need the money. And on the government side, that means we are working either with the government to provide direct support to your program, whether that's purchasing your services or goods directly to the government, or creating the right incentives, whether that be tax or regulatory or other activities, to make the ability for you to bring those services to market much more profitable for yourself. On the private and commercial side, what funding means is that you have a good or service that somebody is going to buy. You can sell a good idea to an investor, but the investor is not your customer. You and the investor are trying to sell to a customer. And if your business does not have actual customers, or address an existing market, or create a new market, then you don't have a business. What you have is a religion, and you're trying to bring on believers. So Again, this is more targeted for some of the young professionals that I've run into who have a really good idea, and if people just believed as hard as they did, then the business would take off. I don't care if you call yourself new space, old space, or whatever you want to call yourself. You're still a business, and you've got to sell goods and services to somebody who's willing to buy them, and that's all it comes down to. Now, there's a lot more detail and complexity about what goes into the funding and the mechanics of regulation and law and policy, and I'm happy to discuss it with any of you that really enjoy pain later on. If you want to hear more about policy and law and regulation, then I suggest we all go in for group therapy. But happy to talk about it at some point. But I want to finish up quickly here by kind of bringing together all the ingredients and talking about how they work together with the chefs. Now, the first part is the goals, the government part. Government part first on goals. If governments want a successful program, then they have to have clear goals and policies. And I cannot stress enough the importance of being able to tell not just yourselves, but the rest of the world what those goals and policies are. So for those of you from government, make sure it's clear, make sure it's constant, make sure it's steadfast, and make sure everybody knows what it is you're trying to accomplish. I am super, super excited about the recent announcement from Australia yesterday about setting up their space agency and the forthcoming policy work. If anybody from Australia wants help on policy work, let me know. I know plenty of things on how to make policy bad, and I can probably tell you where to avoid those, but it's up to you to do the good parts. Happy to help with that. On the capability side, for governments, if governments want to have the capability that they need to either explore, to do the science, or to be the peacekeepers, then you have to help industry, give them access to technology, provide them the labs to do the research, give them the laws and regulations that allow them to do the good things that are going to help you. And finally, on the funding part for governments, you can support, again, the funding through laws and regulations and other things. But then another important part that is often lost because it's stuck inside the space community is stability. Investors in markets love stability. They hate volatility, and they hate the unknown. And that was one of the reasons we really pushed hard for the space resource law in the US and in Luxembourg, not because we're going to be mining asteroids next month, but because the investors wanted to know that we could protect their investment. It's providing some clarity and stability to the market. Now, quickly on the industry side, talking about goals. Understand where you fit in the global market. Not the space market, where you fit in the global market for what you're trying to achieve. And let government know what you're trying to accomplish so that they can help you accomplish that goal. I know it's a joke to say I'm from government, I'm here to help, but I will tell you, at least from my experience in the US government and also dealing with a lot of other foreign governments, I have not met anybody in a government who says, forget the industry guys, screw them, we're going to go do our own thing. Like, they want to help, they want to make things work, because they know, I mean, it's unenlightened self-interest, they know that if you do well, they do well. So they want to see you succeed. On the capability side, engage with the government, get the laws and regulations that you need. Help get that part done. Help them understand what your technical needs are, where they can help you achieve those technical goals. On the government side, go find your customers. Again, your customers are not your investors. Your customers are the people who are going to actually buy your goods and services. But also talk to your investors about what your hurdles and your opportunities are going to be so that they know from the very beginning when you're going to run into problems. If you can get those two chefs, the government and industry, to work together to fully understand how to fully utilize all the all the ingredients that they have in the kitchen, it's amazing what you'll be able to accomplish. You just have to figure out how to get all those pieces to work together. Sometimes they do and sometimes they don't. But I think we have had some amazing experiences on the communication side. We're starting to see it in some of the new space endeavors, and we've seen it before in a lot of the historical exploration and scientific programs. And again, from my background, we've got some amazing successes in the national security side. We've done this before. We have new markets and new opportunities coming forward. I'd love to see a lot of the young professionals stay around and not run into some of the pitfalls that some of us have run into before. So again, thank you for your time. I apologize for not talking about NEOs. I know I let a lot of you down, but thank you. Clay, thank you again. Eric, thanks again, and thank you all for the opportunity.
At this time, I'd like all our panelists, if you could join me on the stage. I think we have about 40 minutes for a little bit of Q&A. I will start off some of the questions for the panelists, and then I've received several questions from the audience. You'll be rewarded by good penmanship, so if I can read it, I will ask it. And, but please have questions keep coming. I think we have a couple more right here. All righty. Just segueing a little bit from Peter's comments as he ended up reaching out to a lot of the youth here that is attending the IAF. What are the challenges that many of you guys face in industry, workforce challenges, bringing in new talent, developing that talent, and the competition that you have from other industries? Fritz, do you mind starting off with that?
Yeah, so let me say, getting young people, young generation on board is a very important issue for this. So we have in our company several actions. So for example, we are a strong supporter of Space Generation Advisory Council, SGAC, which they had their annual meeting just in the week before this conference or this congress here. What we recently started also is a type of entrepreneurship competition. That means we offer young professionals in our company to come up with suggestions for creating an own startup. It is a type of competition. We review it, and we have at the moment 2 proposals where we will give them a temporary chance. They will get a budget, because with their proposals they have to have a very preliminary business plan saying, okay, this could be the benefit of this, and if it is selected, they will get a certain time, a limited amount of resources in order to start it on their own. We are just in the beginning of this. We even do it off-site. That means they are really decoupled from their daily work in order to get there. On the other hand, in industry, and it may be in all continents, there will be a fight for good talents, and because also just walking through this conference here, let me say, take just my example, there are a lot of gray-haired people here, nothing against gray-haired people, but I think there is a huge crowd which will retire in the near future, and we all have the responsibility that there is enough continuity for our industry, for agencies, for everything, because space is not a nice asset to have. Space is an elementary infrastructure for our whole societies.
I have 2 little girls, one's 6, one 8. The 8-year-old wants to be a veterinarian and a dancer, and the 6-year-old, I'm pretty sure, is going to be a dictator and a singer. I'm not sure how those 2 work out, but nonetheless, one of the issues that we face, and it's not just planetary, it's just about any company, is getting a diverse workforce. We have a rule of hiring the best and brightest. We don't care what you look like, where you come from. We want to hire the best and brightest. But what happens is what's coming through the colleges and what's coming through the early professional ranks is that it is dominated, well, yeah.
Obvious.
I mean, let's look at the panel here, right? And you can only hire what is available. And so I would make a very strong plea to elementary school, high schools, universities, bring in as many different people as you can. Because while I'm pretty sure one of my daughters will become a dictator and a singer, I'd like to be able to put, aerospace engineer on the list of options for her, for things to do. So again, trying to get more people from diverse backgrounds into our community. Again, when you're working on such big technical issues, diverse backgrounds and diverse knowledge helps us tackle those really hard goals.
Travis, having 3 daughters in college right now, how many are in aerospace engineering in your family?
There's only one in engineering, the other 2 in international affairs, foreign policy. But I did find it very interesting. They really started appreciating the work that I do in space when some international event takes place, like the Cassini mission or debris generating events. It really got them thinking more about what I did when some type of national or international event took place. And the same thing within our company. When the our younger employees get involved with projects that have a national impact, it really inspires them to keep going further and further.
Thank you. Good question. And I also have 3 kids. My daughter in mechanical engineering, who's made me very proud in taking a job in aviation last summer, so in the aerospace industry. So it's nice to see. I wanted, there's a couple programs we run at Blue Origin. One is a traditional internship for aerospace, mechanical, electrical, software engineers. The other is what I call the new graduate rotation, and that's a program that I personally manage with another member of my leadership team. We bring 10 people through. It's not an executive leadership program, it's a technical development program. For 1 year, we rotate them around the company, and what we found, we've been doing this for nearly 14 years, we found that these folks come out of this program with the most breadth of understanding about the company and the culture, and even a company of 1,200 people like Blue Origin, or even when we were 300 people, we were still a company of a few little microcultures. I like to describe it. Each group runs a little bit differently, and I think that's part of our success and development over the years. So these folks go out, they spend 4 months in each group, they really understand it deeply, and they come out of that with an understanding of how to ask for help at the end of the year. And I think that's really important because you know people around the company that are experts in a variety of areas, and you know who to go to. You don't rely on tribal knowledge or looking it up in a book or an org chart. You know the person personally. Getting back to your question, though, Eric, the challenges we have is in hiring software engineers. And in Seattle, we are in this community where software is king with companies like Amazon, Microsoft, Facebook, and Google have come there for the supply of software engineers. So hiring them is a challenge, and you have to get creative. You have to do all kinds of things. I'm going to think a little bit more about Fritz's idea, and so I'm here to learn, and so appreciate that. Thank you.
Thanks. Yes, we have at Boeing obviously a very robust portfolio of STEM education and internships and all kinds of university outreach and university research partnerships. But to Rob's point in terms of really answering the question, I think it kind of gets back to what Peter was saying during his panel remarks. We are very good at attracting really bright talent fresh out of college into the aerospace industry writ large, and in our company in particular. But maintaining them through those early career years is an area of focus for all of us. I think we've seen people leave. Our satellite factory is in the Los Angeles area. We've seen people, software engineers in particular, leave to go to the entertainment industry, Pixar and the like, and so maintaining their interest and professional development and professional challenges is a key focus for us. And we have a number of programs now that kind of elicit that entrepreneurship, the creativity, and the collaboration across multiple projects and across multiple sites within Boeing to be able to help with that, career development and maintaining that interest and drive through those mid-career years.
Okay, great. You keep the mic, Bruce. I'm going to work my way around the other. A question from the audience: how will launching rockets through constellations be managed? And then the second part is, how is it planned to remove failed spacecraft to avoid catastrophic debris increase of potential collisions?
Okay, maybe I'll let Rob answer the first question. Certainly, we'll, from our point of view as a satellite manufacturer, we'll package them multiples at a time and then pass them over to Rob and others to do the rest. In terms of the end-of-life disposal issue, the concepts that we are designing now have electric propulsion on them, which will enable the spacecraft to be actively deorbited to help preserve the orbital environment.
Thanks, Bruce. Launching large constellations of satellites can be done with a vehicle like New Glenn with a 7-meter fairing, which, as I mentioned earlier, is really a direct result of talking with our customers, and that customer feedback was critical to balance our performance with the volume capability of New Glenn. Launching 20, 30, 40 LEOsats at a time is a unique capability that we can do to multiple planes, and provide the kind of price per satellite metric that our customers are looking for, as opposed to the traditional price per kilogram or price per pound. So New Glenn brings that new capability to the market, especially with the 7-meter fairing. So,
Travis, you want to touch base on the debris mitigation there?
Sure. It's from that perspective, it's a very exciting time. You know, I've wanted to be in the space industry since I was 13 years old, and the innovation that's going on from the satellite side, the launch side, it's very, very exciting times. But it's also a time where there really needs to be that this is the time to leverage the innovation and commercial aspects of being able to ensure that the preservation and sustainability of outer space is continued through not only our generation, but generations to come. And so there's certainly a marketplace to, not only with suppliers like these guys that are doing it the smart way, but not everyone is doing it the smart way. So there's a need for that.
And on the last part of that question, was the question about active debris removal, or what was the?
I think end of life.
End of life?
Removal.
Oh, okay. Well, I don't need to add anything more than let's buy some people some time back.
No, in principle, for industry, I think it could be, if there would be a regulatory demand for having a deorbiting device, it, let me say, could be for industry interesting. It would bring a new level of competition also among us spacecraft manufacturer, and it would have, but I think it is like catalytic converters. There cannot be a few have them, another part have it, otherwise it may be distorted competition if, let me say, US requires it, but you could have it built in Mexico where it's not required, or whatever country, so I do not want to blame someone not following regulatory procedures. So it is either one has to have really a global consensus. And based on this, so previous also panel here addressed an approach to this. I think from industry, one should not be afraid. It could make satellites more reliable and even keep our space clean.
Rob, I got a couple here for you, and I'm going to try to sift through them best as possible. We'll cut right to the chase on the first one. When will New Shepard start taking people above the Kármán line? And then how much will it cost for a ticket?
Okay, I'll start with the first one.
All right.
And then ignore the second one. No. No, the first one.
Really happy about that.
So New Shepard, we're in the midst of a developmental test program. We completed the tests last year. We're building out the fleet right now. The next vehicle in the fleet has been shipped out to our West Texas site, and we're prepping it for what we call a hot fire test. It's a new vehicle off the line, so we load it up with propellants. We fire up the engine, we make sure all systems are go for launch, and we'll probably launch that within the next 6 to 8 weeks, depending on outcomes. So we're very, very close to the next flight of New Shepard. When we put people on is simply when we're ready. There's a lot of safety systems that have to be tested out. We want to gather a lot of data from this flight program. We've designed New Shepard to be autonomous, so it can fly without people, and we'll fly it as many times as we think necessary to demonstrate the design, the redundant systems, the reliability of it. Then we'll put people on board. And as far as a date, within the next few years, we hope by the end of 2018, but we won't do it until we've demonstrated that we're ready to go do it. After that, we'll start to sell tickets for New Shepard. We haven't gone out and announced a price for New Shepard yet, but we'll do that as soon as we're ready, start flying people and getting into the demonstration program. And if you're interested in being among the first to hear about the price, I encourage you to go to our website, sign up for updates, and then you'll be amongst the first to get that information. So.
Okay, and I got a quick follow-up for you. What would probably the biggest technical challenge of moving from a suborbital vehicle to an orbital vehicle in design for you guys?
Well, there's a lot of extra energy there, and we are no strangers to that. We have a team that is a mix of folks with deep experience. About a third of our company is greater than 20 years experience. About a third is less than 10 years of experience. So what we've done is we built an organization that has experience in a multitude of industries, from rockets and spacecraft to aircraft and marine design. The challenges there, obviously, with the speed and energy increases that you require to return from orbital flight, require advances or technologies in TPS that we're not demonstrating necessarily on New Shepard, thermal protection system, what I mean. And then the need for high mass fraction upper stages. You need high energy upper stage, and we demonstrated that with our BE3 engine, which uses hydrogen. Building that high mass fraction upper stage for New Glenn will be one of the design challenges for us. But we've sort of over-thrusted, oversized the first stage to allow us to carry large payloads in and not require that first stage to be at the same level of performance as other reusable vehicles might require.
Okay, great, thank you. I guess this is for Bruce and Fritz, but how much bandwidth capacity is lost to malicious traffic, spam, bots, piracy, et cetera? And what would it mean to recover that capacity? You have any idea on that?
Yeah, I don't know how much IP traffic is lost to that. That's a good question, but certainly, as a satellite operator, interference is becoming a broader problem, both intentional and unintentional interference, and that can be a significant impact on the business case of some of our satellite operators, and working with. I think even ComSpot has some activities underway to not only share orbital position data, but share information on harmful emitters, and being able to identify where they are, and then intervene in order to correct the situation. But there's also technical approaches that can address that as well. So advanced digital payloads can essentially electronically create nulls in the antenna pattern to mitigate either deliberate or unintentional interference and help recover, on the order of 90% of the total bandwidth back. So. Fritz,
I think you mainly said it, but very important will be in the future as a cybersecurity in space communication. That means really new methods, new ways to make this communication secure, and in particular also jam resistant. And because let me say intentional actions, I think the non-intentional actions can be very well maintained. Meanwhile. So it is always a question of what is the purpose of the satellite, what is intended by the intruders in doing it. Yeah.
I'm going to try to paraphrase a question that's very timely a little bit. Given the recent announcement from Australia on their new National Space Agency and policy, what should Australia be doing with its space strategy, policy, regulations, and I guess more so incentives and taxes? I know that, Rob, you had mentioned, your recent move to Florida and other areas where people are incentivized to go. What would it take to incentivize some of your companies to set up in Australia?
Yeah, we already have a very large operation here in a business unit that we call Boeing Defence Australia. There's several thousand Australian employees here, providing really the breadth of defense services across aircraft, across manufacturing, across logistics and refurbishment, software development, mission analysis, and probably the one thing that's missing from that list is space. So I think there's an opportunity for a similarly robust set of collaborations across space, whether it's manufacturing, software development, services, et cetera.
Okay. You just set up shop, so you might not be moving anytime soon, but for others that are looking to do that,
We're growing though, and I think I'd like to just 25 years ago, when I'm dating myself, I was here in Australia with the NASA contingent looking at landing sites for space station crew rescue. And so we had just decided to build the International Space Station and use the Soyuz as the landing site, or landing vehicle, the crew rescue vehicle. So there's a small team of us that traveled all over the country. We got to interact with search and rescue, state police, local folks, and all communities from, including Adelaide, Perth, the Northern Territory, all around the country. And my recollection, and still what I'm seeing this week, is the passion for space, the excitement for this industry, not just from the 5,000 people at this conference, but I saw it out there in the field. They want Australia to be part of the bigger picture, and so I think it's very exciting about the announcement about the agency, what it would take for foreign companies to come in. There's wide open space here. You could you could build launch capability. When I was with Kistler, we were going to launch from Woomera Rocket Range. I'm not sad that I'm with Blue Origin now, but of course we were very excited about the opportunity to launch from Woomera and make that case. And I think there will be many opportunities now with the formation of a global or a national agency. So.
I would just comment the collaboration opportunities for an Australian space agency to collaborate with other space agencies is just exponential. I would say that as far as AGI, our specific efforts, we actually just stood up 2 telescopes as part of our ComSpot network here in Australia. One is in Dubbo, another in the western part of Australia. So we're looking to expand not only on the defense side, but also the civil and commercial side of leveraging the resources and now with the space agency within Australia.
All right, hey, Travis, hold that thought and the mic, because I'm going to, you segued very nicely to my next question from you and Peter. There's a lot of talk and thoughts about the opportunities and risks of transitioning the Space Situational Awareness Network from the U.S. government, the Air Forces, so DOD, so we have a lot on our plate. Let's hand this off to a commercial civil agency. Do you guys, certainly from a bias perspective, AGI, that's what they do, but maybe from a policy perspective, Peter, can you talk about what will go into that and thoughts on that, those opportunities?
Yeah, I guess the one comment that I would provide, I did get to hear some of Dr. Neal's talk from the FAA. Certainly, space traffic management is inherently a non-military endeavor. And there's lots of opportunity where the DOD and other governments of the world could use their precious resources focused on inherently military functions and endeavors. So there's certainly a growing need for commercial and civil aspects that could be offloaded to allow others to use their resources in a much more efficient manner.
From a policy perspective, this is one of those things where I will retract everything I just said in my prepared comments and say space does matter, in that the physics makes this not a military problem. It doesn't make this a commercial problem. It doesn't even make this a national level problem. This is an international level type of activity that needs to be coordinated. So having it coordinated amongst the military needs, the civil needs, but also coordinated at an international level to try to figure out what those opportunities are is the important thing to do. So with the stand-up of the new space agency here in Australia, I see it as an opportunity, as one of the maybe early things for it to tackle is getting involved in an international discussion about utilizing the assets here for space surveillance and space situational awareness capabilities and space traffic management. So that'd be a critical thing to do. Because I have the microphone and I'm that kind of guy, I do want to go back and address one thing that I would love the Australians to help us with on the commercial side as they stand up their capabilities here. One is, as you're developing a policy, there's no difference between what a space policy is and what your national priorities are. There shouldn't be any daylight in between. But one thing where I do see Australia as having a great competitive advantage, and I have friends from the U.S. government and Luxembourg government in the audience. I'm not moving anywhere anytime soon, but one thing that we need, as well as many other companies that are doing things similar to ours, is deep space comms. There happens to be some really great antennas here in Australia that could fill a market need that does not currently exist. So utilizing those capabilities to help the commercial markets that are going beyond low Earth orbit and beyond GEO to do missions is an awesome opportunity.
Okay. Well, I got go ahead.
Oh, maybe just a comment. On the civil-military interaction in space awareness, Germany has a few years ago started a joint, it's called Weltraumlagezentrum. That means it's a civil-military joint center operated by Air Force and DLR, the German Space Agency. And this works quite well. So one clearly from the beginning said in Germany these activities should be not pure military, pure civil, but it is a national action. Clearly it has to come, as you said, in an international environment and context. And okay, on this large antenna in Australia, so to the OHB group also belongs MT Mechatronics in Mainz, a company which built on the world the largest radio telescopes. So we have in Chile 25 antennas of 12 meter, and even here in Australia there are some antennas being built. So it is because I mentioned this also because you said now with the space agency. So we had yesterday discussion here with the South Australia government, and Minister of Economy of Bremen is here, and there was yesterday even a memorandum signed, and potentially we are exploring whether we would not be present here in the near future.
Okay, I got a great kind of and a very timely question. And especially in like last night, yesterday afternoon, they had all the heads of agencies talking about what's going on. And now NASA, or I'm sorry, the Australians will be looking for a new head of agency. Peter and I had the opportunity to talk to your head of agency last night for Pascal. Had a wonderful conversation. And we, back in the US, are going in the midst of choosing our next head of agency with NASA administrator. So to that end, what would be the best person to head the Australian Space Agency? A politician, an astronaut, an engineer, an academic, and what qualities and skills should they have? We call this back at NASA, you know, trying to find the Frankenstein of a leader. You know, you want an astronaut, you want someone, a technical person, you want someone political. So what is probably the strongest quality that you guys see? We don't have to name a person, but just in general.
I'll jump on the grenade. Wow. Not any appropriate answer for that. I think I'll use my previous comments as a crutch, which is I don't care who you are and what your background is unless you know how to use the ingredients and how to make that recipe work. So if you're an engineer who understands politics and understands the funding and the budget process and can make those things happen, fantastic. If you're a politician who knows that you need to rely on a really good engineering corps to tell you how to get the job done, but then can work the political process and get you the money that you need, that's awesome as well. But having an understanding of those qualities, but also understanding where you don't have those skills and how to bring those into bear by either a deputy or somebody else who can help that's the type of person. Is that a good enough non-answer for everybody?
Yeah.
Yeah. All right. Good.
I think you provided sufficient cover for everyone else, so I'll move on to the next one, and I'll shift it to you, Bruce. You have a tremendous amount in your portfolio and what you're overseeing. Can you talk a little bit about the XS1 program that you guys were awarded from DARPA? Any light you can shed on that?
Yeah, sure. We are working in partnership with DARPA, the U.S. Defense Advanced Research Projects Agency, to develop kind of a next generation small launch vehicle that has some ambitious reuse and reflight goals. We're kind of at the early stages of that project, and so we're hopeful that there's some good technology development that comes out of that, and the ultimate aim of all the DARPA programs is for them to transition into operational capabilities, and so we're hopeful that that the technologies will pan out such that they get brought into use. But it's as the nature of DARPA projects, it's got some high technology and the technology risk in there, with some potential breakthroughs. The DARPA government employees are kind of famous for calling it DARPA hard, and so if it doesn't have an element of DARPA hard in it, then they won't pursue it. And so working closely with them to advance these technologies, and really a generation or two after the current capabilities of launch vehicles that are in development, hopefully some of these technologies will be brought to bear.
Okay, great. Rob, something you didn't touch on, but it is very critical what Blue Origin is doing, is the work that they're doing with the suborbital community in some of these small payloads to testing that. Can you talk a little bit about the work that Blue Origin has done with the suborbital community and the various payloads and whatnot?
Yeah, sure. We had a breakfast this morning that we hosted with NanoRacks, who we're partnering with for offering suborbital science payloads on our New Shepard platform. New Shepard, from a price and performance standpoint, is a really unique capability that's entering the market now, and the breadth of interest from universities, from international space agencies, and from companies around the around the world has been really outstanding. Dr. Erica Wagner is our point person at Blue Origin. I'm sure many in the room have met her. She's here at the conference. She's working with Jeff Mamber and his team at NanoRacks. Jeff is also here. Our manifest is completely full for the next several years, and we're looking to add capacity so we can fly more payloads. But we really are excited about using New Shepard as we're kind of painting it as a pathway to International Space Station, and being able to fly your experiments quickly at a relatively low cost, and doing it multiple times before you can take it up to station. So, okay.
Great. Peter, did the asteroid redirect, the cancellation of the asteroid redirect mission, did that have any impact on planetary resources and on the morale and the division or the companies going?
I don't even need a microphone for that, no.
Okay. Yeah.
No, I mean, we weren't involved in that program anyway, so, I mean, it was sad to see the program go, and it was, as any of those large programs are, regardless of what they are, when you see that much time and effort and manpower put into making those things happen and they get washed away, you feel bad for the staff that's there, but no impact on our company, no.
Okay. What do I have else? Large and small constellations. Back in the 90s, there was talk of these huge constellations, and it was a lot of talk, but then they ended up floundering. We have the same talk going on now, and it seems to be a little more bring fruit to the bear on that. Can you talk about the differences that you saw, Bruce, on the large constellations of the past and how it's different now?
Yeah, I mean, certainly there's a strong feeling among a lot of folks that it's different now. I think time will tell for sure. But I think some of the things that are different in the current environment, number one is, as I just said in my remarks, the demand for bandwidth is so great that we need multiple modalities and multiple orbital regimes in order to satisfy all of the demand that's out there. The other key difference, of course, is technology. As satellite technology has advanced and become more digital and more flexible, it really becomes a more direct compatibility, both in terms of price per bit and capability with terrestrial systems. And so I think there's less likelihood that there's going to be some technological breakthrough on the ground that would render these satellite systems obsolete. And so I think those are some of the key differences that we're seeing is just the technological breakthroughs on the space side and the insatiable demand from the user side.
Okay, great. Thank you so much. Peter, just shifting back to you a little bit. In the end of 2015, the Commercial Space Launch Competitiveness Act was passed by Congress, signed by the President. It had a lot of provisions to help foster the commercial space industry in the U.S., and some of it had to do with resource mining. Can you talk a little bit about that provision in that legislation, and a little bit the impact that may have on with the Outer Space Treaty that we often talk about of 1967?
Yes. Are there any space lawyers in the crowd? All right, good. Good. I think I can take you all. It's a small enough number. I'll at least live. So, as the saying goes, if there's one lawyer in town, he stars, and if there's two, they're rich. There's a multitude of views on the impact of the U.S. law on the Outer Space Treaty. My own view, very obviously, is that the U.S. CSLCA is in not only complete alignment with the Outer Space Treaty, but actually reinforces the treaty and provides definition and actually provides enforcement that is not found in the treaty. As we were going through the development of the treaty, one thing that was very clear from both the House and the Senate was that there was no desire whatsoever to upend the treaty, to subvert the treaty, but to make sure that everything we're doing was in complete compliance with the treaty. I mean, that's even why the phrase is in the law that this is done in compliance with the Outer Space Treaty. And all it says is if you go to an asteroid and you pull resources off of it, you own those resources. Nothing more, nothing less. You don't get title to the territory. You can't claim territory. All these things that it says in the treaty you can't do. And I think the overall impact that had well, actually there's a few impacts that had. One on the investor and customer base was that, holy crap, this is real now. These guys are actually convinced 535 people in the U.S. government that this is the right thing to do, and then send it to the Oval and the president signed it. That's pretty amazing. And then it also got other countries to look at it and go, well, the race is on. Like, we have to start thinking about this as well, because it's not just about the business, but it's also access to strategic resources. You know, game on. So Luxembourg quickly followed suit and not only passed their own law, but passed one that actually goes a step further and invokes Article 6 of the Outer Space Treaty, which is, again, since many of you are not outer space lawyers, Article 6 is authorization and supervision, which means that a country is required by the treaty to authorize and supervise what your citizens do in space. So the Luxembourg law allows us to operate under Article 6. And then you see the Emirates is doing something similar. So it's really just been this great cascading effect that, okay, this is a real industry, things are moving forward, the laws and regulations are getting in place, this is happening. So it was a great catalyst to get all that rolling.
Okay. And so I kind of want to go down seeing that we're talking about the policy issues. Bruce, you had mentioned a little bit about smart policy and spectrum management. Rob, you know, being from the launch side of the house, you're dealing quite a bit with FAA's Office of Commercial Space Transportation. Travis, you know, the policy on the space situation awareness and where it's going to go, working with the Air Force and so on and so on. Can you guys all maybe address a little bit some of your policy, maybe main policy concerns, and how we can move these issues forward and where it's good, where it needs some help a little bit?
Sure, I'll jump in. Yeah, I think you know, you mentioned some of the key ones. I guess one for us, sort of selfishly as a U.S. manufacturer that's in that realm, is Ex-Im Bank and getting Ex-Im Bank back to a quorum to authorize that. That's a big issue for us in the satellite business, but also our commercial airplanes activity, just really leveling the playing field for U.S. business, you know, relative to our international competitors. And then in the spectrum arena, you know, both with the FCC, but then the regulatory country-by-country regulatory agencies around the world to enable and preserve access to satellite spectrum and to especially new spectrum, you know, in the higher bands that has yet to be exploited either by satellites or by terrestrial, to make sure that you know, satellite maintains a market access to foster competition and innovation in satellites. So those are probably my top two. So I'll leave it there.
Yeah, good question. Two areas. One is around the ITAR and maybe freeing some of the restrictions on particularly human spaceflight technologies, freeing some of those up from the ITAR, the International Traffic in Arms regulations. The second one is about appointing FAA as the single point of contact for licensing a commercial launch from a federal range. So currently, as we plan to launch from Cape Canaveral Air Force Station, we need to get a license from the FAA, and we need to work through the U.S. Air Force for other oversight, and we want that designation to be a single point with the FAA so that we can choose the services from the Air Force as we need them. So those are two that are most important to us now.
From a policy perspective, thanks to this guy, we cleared our biggest policy hurdle, which was in the commercial world, use commercial services wherever practical. Our biggest competitor currently in this particular area is it was a great public service in years past because no other entity could provide it, but the free space track services being provided today by the U.S. Air Force. Even though the U.S. Air Force, in other regards, they're also a customer of AGI. But it's really the enforcement of the 2010 space policy that Peter and his team put together.
Maybe one should mention another area where, let me say, there may be no fair competition globally. It is on sales of higher resolution optical and radar data. In particular in radar domain. So there are many national regulations. ITAR in the US applies. Germany has an own law for it. Now most European countries are introducing laws, but there is not really a harmonization. So in particular, there is, if one looks to export of imaging high-resolution satellites, there are let me say, or it's a distorted market partially, based on this, depending from which country you are coming. So these are more national, let me say, unbalances, but nevertheless, for industry, it's not an easy situation.
Mary and Robbie, how are we for time? We got a couple more questions, or? Okay. Okay, sounds good. Well, Fritz, seeing the mic, I have a question for you from the audience. What are your views on the critical elements required in the value proposition space in your national security, defense, and homeland issues?
Is it crypto issues?
Yeah.
Yeah, no, I think this is a very important, essential point for the future. There are new ways of encryption, in particular quantum cryptography is on a physical basis developed, proven that it works. 10 years back, nobody would have believed it. It was considered more like magic rather than that it can be really done physically on ground. There are some universities which demonstrated it, and recently China on a satellite experiment. And I think this type of encryption in a way, has to be further engineered, explored. It was the first demonstration that from a basic principle, but I think, let me say, countries have to go, if there's national security involved, in the direction of having these, let me say, really secure ways of encrypting critical information, because it's really I usually take the example. We do the Galileo satellites. There's a James Bond movie where the clock of navigation satellites are mistuned and the missile misguided. That means this is not science fiction in this James Bond movie, it's reality. Let me say, when you design the satellite, build it, you know you only have to access a clock and tune it like you do tune your alarm on the bedside.
Peter, I got a regional policy question for you. How are the universities, how best can universities work with the government in Australia to ensure that research capabilities that are core to the emergent space agencies? So the partnerships, I guess, with the universities here, the success that you've seen in working with the government agency.
I think where I've seen universities really provide value, whether it's in the US or places I've been in Europe or in Japan, is where they're really tied into two things. It's what industry is looking for and also what the government needs are. There are some basic R&D that is just not something that industry will take on because it's the amount of money that gets eaten up by that it really eats into the profit and of the company. So being able to undertake some really basic R&D in space areas is critical for universities. But then again, for the government side, being useful to the government on whatever their exploration plans are, their science plans are, there's some basic science things that that universities have done extremely well on in the past. And they've also been great innovators. You know, it's that line, you know, we're out of money, so now we have to think. Universities are more cost constrained than most governments are, and they come up with some really interesting, innovative things. I mean, let's not forget where Surrey satellite started. So it's those types of capabilities of figuring out how to do something new and novel as well.
Okay. I have a final question. It's for everyone. And it gets back to the original question that we started with about the workforce development. And I'm going to read it and ad-lib where I can, but what are your thoughts for that young professionals and early career must be financially supported to attend conferences like the IAC to highlight young professionals and technology programs, accomplishments, what they're doing to highlight these papers. We're pretty good at recruiting, but we must retain the best and brightest talent. So in farewell parting shots, so, you know, what can we do better to kind of enhance that the young professionals are here at conferences? I know, I think Clay may have stepped out, but I know for a fact, like Clay Morey, and I know most folks on the stage is very involved with a foundation that he started, the Future Space Leaders Foundation, where they have sent several students, about 6 or 7 students, out to this IAC conference. And through, how many? 9 students, 9 students this year, and they did similar Guadalajara. How can we, and as I said, all of the organizations here on the stage are very active in doing that. How can we reach out to do it better? And as I guess we said earlier on the stage, how do we change it from all males in dark suits for next year's panel?
Yeah, sure. So I think there's a lot packed in there. Certainly for our young, early career employees, opportunities to attend conferences like this are really tremendously valuable. In addition to encouraging them to write papers, another venue for them is working in the display booth. We have some really cool demos and 3D kinds of immersive environments located in our booth. And a lot of those were done by our early career employees, to take some of the technologies that we're developing to create, a little more interactive, a little bit more kid-friendly versions of them to display in the booth. But, that gets them here into the conference, interacting with people in our booth, but also just exposed to the sessions and all the other great networking that happens at the conference. So I think, if you're creative and passionate, you can find ways to get yourself into these really unique events.
Don't have much to add except that we also took a group of 4 of our young engineers out to the Space Symposium last year, and along with the new Shepard rocket there, I mean, it was just a really amazing opportunity for them to interact with a customer base, a broader technology base, and just didn't know how that would go, but it went fantastic. I mean, it was just a great opportunity for them. So.
Yeah, I would, everything these guys have said, we also do the same as getting them exposed through writing papers, going to conferences, particularly international conferences. So that's already been said. I would like to share one story, and lots of credit to SGAC. I was at the closing dinner on Saturday night, and I met a young lady. Her name was Marianne from Kenya. She lives in a village in Kenya. It was the first time she's ever been out of Kenya. She's here at IAC because of scholarship she got to come here. Her entire family has never been out of their village. And she was describing this story to me about how much she wants to be in space. She actually got emotional. It just inspired me more to really do more on this topic of helping the younger generation realize their dreams and inspiring them to continue what we've all been a part of.
And if I remember correctly, wasn't she working on small set development or something?
Yes, satellite communications. That's exactly right. Talk about bandwidth.
I think in addition to bringing people to these conferences, I think there's an opportunity for mentorship that just doesn't really exist, I think, in a lot of places. Being able to be a young engineer and spend time with somebody who's been doing it for 30 years, or if you got dropped on your head as a young child and want to work in policy, I'd love to spend time with you. I'm sorry that you'd want to work in policy, but I'll help you anyway. And having that collaboration back and forth, though, because I think young people don't know enough to be scared, but those of us that have been around too long know so much that we stop dreaming. And so putting those two back together, I think, is beneficial for both sides.
Rich, you get the final word.
Yeah, okay. So when the IAC in Australia was announced, clearly we expected a lot of people want to submit papers, etc. And one of the criteria before submitting a talk was also who presents it, and age was not a positive sign. So we preferred to select and to have papers submitted by the young ones. We don't have an own booth, but there's a booth by Bremen, where also some young people from our company are here. And you mentioned SGAC. So we have a scholarship, or we support, and there are 2 students here at the moment paid also travel by OHB. We do this for a couple of years, and I can, all industry leaders here, only recommend. SGAC does a marvelous job on this. So we have, they do a competition, so it's even a topic. We get even good resumes and papers by people, so it's really a potential reward. We even hired young professionals from SGAC, and by this we had in the past, now there's a Spanish student, one is German, also may happen, if he has a good proposal. We had a student from Nigeria, from Mexico over the last year. So really all over the world, Indian, making it possible to participate in the IAF Congress.
Well, it has been an honor and a privilege for me to share the stage with you gentlemen and all the insight and intellect that you've been able to provide today. I can't thank you enough, and if I can get a good round of applause for all our panelists. And I think that concludes this session, and I don't want to be the one holding up everyone for lunch, so I believe this panel is now adjourned.